This video is brought to you by Twistaroma, an independent analytical laboratory dedicated to aroma and bioactive compound profiling. You know that incredible smell of your favorite coffee or the unique character of a craft beer? Well, that's exactly what we're going to break down today. To really get to the heart of these complex aromas, Twistaroma uses some seriously state-of-the-art tech. We're talking about their flagship tools, like comprehensive gas chromatography and high-resolution mass spectrometry. Think of these as the powerhouse instruments that can decode even the most intricate chemical signatures.
And this isn't just guesswork. Their work is built on a rock-solid scientific foundation. I mean, with 22 peer-reviewed publications, 15 scientific posters, and strong academic partnerships, you know this lab is at the absolute forefront of analytical chemistry. They're not just running tests, they're genuinely advancing the science.
So today we're going to present one of their peer-reviewed publications from the journal Brauwelt International. It's a perfect example of how all this expertise gets applied to a real-world problem, one that pretty much every brewer on the planet has to deal with.
And that problem is what we're calling the hopping method dilemma. See, for a brewer, one of the most critical decisions is when to add the hops. It sounds simple, right? But it's a huge deal. The timing, whether you add them during the boil, right after, or way later, can completely change the final aroma of the beer.
So this begs a really important question for the industry. If you've got this amazing hop with a unique character, like the Barbe Rouge hop, which is famous for its red fruit notes, how do you actually unlock its true aromatic potential? That is exactly what this study wanted to find out. To figure this out, the researchers tested 3 of the most common hopping methods out there. First up, you've got late hopping, which is adding the hops near the end of the boil. Then there's the whirlpool method, where they go in right after the boil while everything's still hot. And finally, dry hopping. This is when you add the hops much later, after fermentation is already done.
Okay, so picture this. You've got 3 beers, all made with the exact same ingredients. The only thing that's different is when the hops were added. Now the fun part begins, decoding their aroma. The team used their high-tech analytical platform to create a super detailed molecular fingerprint of each beer to see precisely how they were different.
So how in the world do they do that? Well, the workflow is pretty ingenious. It starts by concentrating all those tiny aroma molecules from the beer. They use a technique called stir-bar sorptive extraction. You can think of it like a tiny magnetic sponge that soaks up all the aroma. From there, the sample goes into the machine for analysis, which creates a complete aroma map. But this is where the real magic happens. They use a technique called gas chromatography olfactometry, or GCO. It is such a brilliant combo of machine and human. On one side, the instrument is separating every single chemical compound. At the very same time, a trained person is actually smelling the output, pointing out exactly which molecules are creating the smells we perceive. It's the ultimate bridge between chemical data and what we actually experience.
All right, so what did all this incredible analysis actually uncover? Let's get to the results, because this is where we really see how to unlock a hop's full potential.
Get this, across just those 3 beers, the analysis identified a staggering 208 different volatile compounds. That just gives you a sense of the insane complexity hiding inside a beer's aroma. But as it turns out, not all of them are created equal.
And here's the crucial part. When the researchers used that olfactometry technique to filter for only the compounds you can actually smell, the odor-active ones, the difference was just night and day. The dry-hopped beer had 38 of these key aroma compounds. That's nearly double the 19 found in the late-hopped beer. It's a perfect visual of just how massive the impact of the hopping method is.
And digging in even deeper, the analysis was able to pinpoint the exact molecules that give the Barbe Rouge hop that signature fruity aroma. The study identified 5 specific esters that the sensory panel described as having these beautiful red fruit and strawberry notes. And here's the kicker. All 5 of these strawberry molecules were only found together in the dry-hopped beer.
And that all leads us to the study's main conclusion, spelled out right here. If you want to get the most of that amazing red fruit aroma from the Barbe Rouge hop, dry hopping and whirlpool are without a doubt the most effective ways to do it. This isn't just an opinion anymore. It's a precise, data-driven answer. Now, this kind of incredibly detailed analysis isn't just for beer, you know? So it might make you wonder, does your product, whether it's a fragrance, a food, a cosmetic, does it need this kind of analytical precision to truly shine? Because this level of detailed profiling is exactly what Twistaroma does day in and day out. They offer tailored services for all kinds of industries: food, fragrance, cosmetics, helping companies really understand what's inside their products, lock down quality, and innovate with total confidence. So if you're working on something and you've hit a complex aroma challenge, get in touch with them. The email is contact@twistaroma.fr. Their tagline really says it all. It's where science meets your aroma challenge.